workflow for this particular worked problem. We've got something like a telephone pole. It's about 15 feet tall. And on that telephone pole, we've got a cable attached to the top and attached to a point on the ground with a tension of 3,000 pounds in that cable. So we're asked to determine the moment that the tension force, this force up here, exerts about the base of the pole down here. So once we find the vector that represents this moment, we're also asked to find the magnitude of that vector, which is going to be the overall magnitude of the moment about the base. So when we have something like this, it's in complete 3D space. I like to use the vector calculation for the moment. So the moment is going to be equal to R cross F. So the R vector is the vector from the point we're taking the moment about. I'm going to call this point A down here at the bottom to the point the force is applied to. So going from A to B, I'm going up by 15 feet in the y direction. So my R vector is going to be 0 in the x direction, positive 15 in the y direction, and 0 in the z direction. Z direction is coming out of the board towards you right now. And so that is all in feet. F is going to be a little more complicated. So it's got an overall magnitude of 3,000 pounds, but we need to break it down into x, y, and z components. So to do this, since I've got this problem set up in this particular way, I know that the cable is going down by 15 feet in the y direction, over by 3 in the x direction, and back 15 feet in the z direction. I can use those numbers to my advantage. So the overall magnitude is 3,000. I'm going to multiply that overall magnitude by a unit vector in the same direction. So a unit vector has a magnitude of 1. So if I multiply 3,000 by the unit vector, I will get the components in each space. So to do that, I need to determine basically how far per foot I'm going. So the overall length from here to here is going to be some value h for the hypotenuse, and h is going to be equal to the square root of x squared plus y squared plus z squared. So 3 feet plus 15 squared, or 3 feet squared plus 15 feet squared plus 15 feet squared, or negative 15 feet squared. So I've got x is 3 squared plus y. In the y direction, I'm actually going down by 15 feet, so negative 15 squared. And in the z direction, I'm going back, also negative, so negative 15 squared. And so the length of this cable, that's what I'm finding here, is that h is that length of that cable. It ends up being equal to about 21.4 feet. All right. So the x component of my unit vector is going to be 3 over the overall length. So 3 over h, my 21.4 feet. My y component, again, I'm going down. My force is going down in the y direction, so it's going to be negative 15 over h. And my z component is also negative 15. I'm going back into the board 15 feet over hypotenuse. So negative 15 over h. So with that, if I multiply 3,000 by each of these components, I'll find my force vector, which is going to be roughly equal to 420.08 in the x direction, negative 2100.42 in the y direction, and negative 2100.42 in the z direction. And each of these components is going to have a unit of pounds. So at this point, I just need to do r cross f. So r is this vector here. I'm going to do r cross product with f. The order in which this is done is important, so you can't do f cross r. But if you do this calculation, either with software like MATLAB, or there's ways to do the cross product alone, you should end up with a moment vector equal to negative 31,506.3, 0 about the y-axis, and negative 6301.2 in the z direction. And this is, the units are going to be, since we had feet and pounds, it's going to be foot-pounds of torque. So this right here is the moment vector that the tension force exerts about point A. So the last thing I'm asked to do is find the overall magnitude. Right now I've got the x, y, and z components of that moment vector. To find the overall magnitude, I'm going to do, and this is the vector, this is just the magnitude of that vector. It's going to be square root of x squared plus y squared plus z squared. So negative 31,506.3 squared plus 0 squared plus negative 6301.2 squared. So if I go ahead and do this whole calculation, I can solve for it, and I get m is going to be equal to 32,130 foot-pounds. So that is the overall magnitude of the moment that the tension force of 3,000 pounds exerts about point A. So with that, we found the moment vector and we found the magnitude of the moment, and that's what we're asked for in our problem. So thank you for watching and hope to see you again.